Today we're going to do 9-1 day 3. So at the top, just make sure you're writing 9-1 day 3. It did print funny. So this is on page 5. And we're sticking with the same objective. Use properties of radicals to write equivalent expressions. Radicals with the same index and radicand are called like radicals. You can add and subtract like radicals the same way you combine like terms. So if I'm talking about like terms, I'll write an example over here. If we had 2x squared plus 3x plus 5x squared, the only two like terms we have here are the x squareds because the variable and the power are the same. So we get to add our 2 and 5 to get 7x squared. Notice that the x squared part is still the same, and then I have my plus 3x is not going to be able to be combined. So we're going to do something similar. With like radicals, when they say the same index and the same radicand, that means that if they're both square roots, it's good. They have to have the same number underneath as well. I can't do a square root of 3 and a square root of 2. I cannot combine those, okay? Nor can I, if they're the same here, but they have a different index, I would not be able to combine these guys. Everything has to be the same with that radical sign and underneath. So we are going to start by adding and subtracting them first. Looking at this first guy, we have 5 square root of 7 minus 8 square root of 7. Those square root of 7s are exactly the same. That means that our answer is going to have a square root of 7. To find the number in front, we take the numbers in front of these, and we do the operation that they're asking. 5 minus 8 gives me negative 3. Now I'm going to see if I can simplify this. I'll write our perfect squares off to the side. That was our first few days. We talked about if we can simplify, then we will. And we talked about simplifying using our perfect squares. If we could divide by any perfect square, then we are able to simplify it smaller. Perfect squares, I'm listing off to the side right now, are just found by doing 2 times 2, 3 times 3, 4 times 4, and so on. Now there's more, but we only went to 12. We can keep going 13 times 13, 14 times 14. So none of these can divide 7, and so I cannot split that up any further, and that one's done. Next one, we have 9 cube root. See that little index of a 3? Cube root of 2 minus 3 cube root of 2. The cube root of 2 and the cube root of 2 are the same. It has to be the same when we are adding or subtracting. And so because it's the same, we're going to keep that part the same, cube root 2. And the number in front is found by doing 9 minus 3, which gives us 6. Again, I'll check to see if I can simplify this guy. We wouldn't use perfect squares because this is a cube root, but we are not learning cube roots right now, so it is fully simplified. Next one, number 3, 6 square root of 11x plus 9 square root of 11x. Square root of 11x, square root of 11x. That part is the same, so my answer will have a square root of 11x. My number in front is found with that operation. This time we have 6 plus 9. That gives us 15. I have a square root. We've learned how to simplify those. 11 cannot be divided by any perfect square, and my x is only a single x, and so I don't have any pairs to come out of that either. Next 3. We have square root of 3 minus 5 square root of 3. So I see that the square root of 3's are the same, and so I'm able to do this operation. I know my answer will have a square root of 3. In front of this, very similar to if I just had an x, really an x represents 1x. Well, a square root of 3, if it doesn't have a number in front, it's really a 1. They just don't write it. So I need to know that in order to do the operation. 1 minus 5. 1 minus 5 gives me negative 4. I cannot simplify this any further, so I box it, and that's my answer. Number 5, 2 square root of 11 minus square root of 2 plus 3 square root of 11. Sometimes you will have only some that can combine. That is fine. This guy is not the same in the middle. That square root of 2, that 2 messes it up. So he cannot be combined with anything. Just the square root of 11s can. So I have square root of 11. And so I'm going to look at just the numbers in front of that guy. I have a 2 there, and then I have a plus 3 there. That gives me 5. Now I can't just ignore this guy in the middle. I need to write him after. So I'm going to write minus and then my square root of 2. This is as far as I can simplify it because this 11 and this 2 are not the same number. These cannot be combined. So this is my final answer. Last one of this type, we have 6 cube root 3x plus 2 cube root 3x. Cube root of 3x is exactly the same. So we leave that as cube root 3x. And then we take the numbers in front, 6 plus 2. That gives me 8. I cannot simplify that because we did not learn cube root simplifying yet, so we're good there. Next section, the first 6 we did, we had like radicals. Sometimes you will have to simplify first, then add or subtract. We simplified in our previous day 1 and 2 of this section, and so we're going to use those methods to help simplify it. Right now, for number 7, I have 10 square root of 5 plus square root of 20. The 5 cannot be divided by any of the perfect squares we had listed above. If you forgot them, rewind the video, write them down, and then jump back here. Square root of 20 can. I can actually split square root of 20. This was our product rule. It said I can rewrite it as square root of 4 times 5. 4 times 5 is 20, so I did not change the value of that. I still have my 10 square root of 5. I still have my plus sign. That's not changing. Still have my 10 square root of 5, still have my plus sign. My rule says, hey, you can also write them under their own radical. We did that last lessons. Square root of 4 is perfect. So now I get to write it as 10 square root of 5 plus 2 square root of 5. The square root of 5 is not perfect, so it's stuck underneath there. But now we are back to examples like we just did, 1 through 6. I have the like radical, so that square root of 5 will stay the same, and all I have to do now is add my numbers in front. 10 plus 2 gives me 12, and that's simplified as far as it can go because the 5 cannot be divided by a perfect square. It works for letters as well. Square root of 3x minus square root of 12x. They are not the same, so I cannot subtract them. This guy really has a 1 in front, so I will write a 1 when I rewrite this guy. Square root of 3x. 3 cannot be divided by a perfect square, nor can I pull out any x's. So that's going to stay the same. My minus sign is still there. My 12 and x can be split up. And I can even split up my 12 further into 4 times 3. 4 is perfect. That's why I'm picking it. If there was another perfect square that was bigger, I would use that one. 1 square root of 3x minus, I can separate these guys. 4 square root of 4 times square root of 3 times square root of x. And I can continue simplifying in this manner. Square root of 4 was perfect. That's 2. The square root of 3 is not perfect. It's stuck underneath there. The square root of x is not perfect. There's no partner to come out. It's only a single x. So these two can actually get multiplied back together under one radical sign. Remember, we're allowed to split it up when it's underneath one. We're also allowed to put it back together when it's under the same one. So that's why we're allowed to write it just like that. Now we have those like radicals again. And now I just do 1 minus 2, and that gives me negative 1 square root of 3x, which just like we don't write negative 1x, we just write it as negative x. Same idea here. We would just write it as negative square root 3x. And that would be our simplified final answer. Going to the next page, the title for this above number 9, let's write multiply. That printed on the previous page on accident. So we are multiplying these. Our rule said that if they are underneath the same type of radical, we can put them underneath and multiply them together under one radical. So that's what we're going to do. We've done this. So this is kind of just review. We've done this before in lesson 9.1 day 1 as well as 9.1 day 2. So you can always look back if you need some extra help there as well. Square root of 3 times square root of 10 gives us square root of 30. I check my perfect squares. None of them can divide it, so it's simplified. Next one, I have square root of 2a times square root of 9a cubed. Now there's more than one way to multiply. I could just multiply and then simplify. If you wanted to simplify first, then multiply, that's fine. I prefer to multiply and then do all my simplifying at the end so I don't have to do it twice. So I have 2 times 9 gives us 18. And then a, remember, has a power of 1 times a. We did this in chapter 6. Same bases, oops, I'm going to do a different color. Same bases we add when we are multiplying. So power of 1 plus power of 3 gives us a power of 4. I can simplify this further by splitting up my 18 into square root of 9 times square root of 2, and I can even write my a. My a is to the power of 4. That means I have 1, 2, 3, 4 a's. Now I'm writing them in groups of 2 because we talked about this last lesson. Groups of 2 can come out of square roots, okay? If this was a cube root, it would be groups of 3. Fifth root, it would be groups of 5. So since it's a square root, I write them in groups of 2 and see how many can come out. Since we're talking about it, I'm just going to circle my groups. I have 2 groups, nothing left over. So I will be able to write this as square root of 9 becomes a 3. The a has 2 groups, so we write a power of 2 for that 2 groups. And then my square root of 2 is stuck underneath. It is not perfect, and that's our final answer. Number 11, sometimes we're going to have numbers on the outside. Those numbers on the outside, negative 1/2 times square root of 32c to the 4th times negative 4 square root of 8c to the 8th. The numbers on the outside of the radical sign are allowed to be multiplied together, just like the numbers underneath are allowed to be multiplied together. You cannot mix and match though. If it's outside, it can only be multiplied with an outside. If it's under, it can only be multiplied with an under. So we multiply negative 1/2 times negative 4, that gives us a positive 2. And then I go ahead and I multiply my 32c to the 4th and 8c to the 8th. When I multiply 32 and 8, I get 256. C to the 4th times c to the 8th gives me 12 c's altogether. Remember, we add exponents. And now I can check to see if this is a perfect square because it's fairly large. My other numbers, 2, 30, none of those were perfect, okay? We've only listed our perfect squares to 144. So if you want to check to see if this is a perfect square, you can type this into your calculator, or you can continue on from our 144. You can do 13 times 13, see what that is. 14 times 14, see what that is. 15 times 15. 16 times 16. Well, when you do 16 times 16, or you do the square root of 256, it gets you 16. So I have 2. Remember, 2 on the outside means we're multiplying. So 2, times 16. And then I do the same thing with my c's. If there are 12 c's, I want to know how many groups of 2. Well, there are 6 groups of 2 with none left over. So now I have no more radical sign because everything was perfect and had no remainders, no leftovers underneath it. So now I get to multiply it together. 2 times 6 is 32 times c to the 6th power. Square root of 3 times square root of 27 gives us square root of 81. Square root of 81 is one of our perfect squares, so it just simplifies to 9. Next one, negative 3 times the square root of 6 times square root of 18. Negative 3 is still on the outside, and then we can do 6 times 18, which gives us 108. We've simplified 108 before. We did that the first day. We saw that 36 could divide it. And when you divide 108 by 36, we get 3. So it's allowed to be separated into square root of 36 times square root of 33, because it's still equal the same thing. I still have that negative 3 being multiplied on the outside. Negative 36 is a perfect square, that's why we picked it, times square root of 3 is stuck as it is. And so now I have negative 3 times 6 gives me negative 18, square root of 3. Can't simplify that any further, so he's done. Last one here, 7 square root of 5x times 3 square root of 20x to the 5th. Again, multiply all the numbers on the outside, so 7 times 3 is 21, and multiply everything underneath the radical sign together as well. 100x to the power of 6. Remember, there's really a power of 1 here, and we add our exponents when we're multiplying with the same base. That was something we learned in chapter 6 at the start of this year. Square root of 100 is perfect. It gives you 10. X to the 6th power, we think, okay, it's a square root. We need groups of 2. How many groups of 2 are in 6? If you need to draw it out in groups of 2, go for it. Totally fine, okay? I have 6 x's there, and that means I have 1, 2, 3 groups of x's. So x to the 3rd power. After that, no number, no letter is left over in the radical sign, so I get to just multiply these guys together for 210 x to the 3rd power. Last piece we're going to talk about is multiple operations. You'll notice I'm skipping over 16 and 17. So I will do mixed operations. First method is called the distributive method. And we're going to do exactly that. We'll distribute square root of 5 times square root of 3, which is square root of 15. And then we distribute that square root of 5 to square root of 75, and we get 375. So we can split up 375 into the square root of 25 and the square root of 15. This guy still comes down, so we still have square root of 15 to start and a subtraction sign. Square root of 25 winds up being 5, and the square root of 15 stays. Now we have like radicals. Remember, there's a 1 in front of that, so we have 1 minus 5 gives us negative 4 square root of 15 for our final answer. The next method is doing the parentheses inside first. So we're going to do the same thing. We're going to look for like radicals. Square root of 5 and square root of 20 are not the same, so we see if we can simplify it. Square root of 5 is already simplified, but square root of 20 can be split into square root of 4 and square root of 5. That gives us 2 square root of 5, and everything else in that problem has to come down. We didn't touch the square root of 2 on the outside. We didn't touch the parenthesis. We didn't touch that first square root of 5 or the plus sign. Now that they're like terms, now we can combine. Remember, there's really a 1 in front there. So we have square root of 2 times 3 square root of 5. And now this is important. Remember, you can only multiply numbers together if they're either outside the radical or underneath the radical. We can't do a 1 and 1. So only the 2 and the 5 can be multiplied together, giving us 3 square root of 10. We can't simplify that any further, and that's it for our lesson today. We're going to skip the bottom part. We are not doing that in our lesson.